Hey guys, today we're going to be doing our second video talking about multiplying monomials by polynomials. So to start off with, I kind of want to remember those rule of exponents, so just jot them down to help you remember. These are the big guys that you're going to need today in order to multiply monomials by polynomials. This multiplying like bases is going to be your best friend today. So if you're still struggling on how to do that one, please let me know because we need to make sure you understand that one before you move on. Okay, so let's talk about the distributive property. So distributive property you guys have used a lot in school. The distributive property basically just says this. If I have a 3 on the outside and I have x minus 2, I take that 3 and I distribute it to each thing. This definition sounds confusing, but what I just wrote on the board, that's what you're really doing. So don't overthink it. And that's really all we're doing today is using that distributive property. So how do we use it with monomials and polynomials? Well, what's going to happen is you're going to have a monomial outside, and then behind it is going to be a polynomial. So we need to multiply that monomial by each polynomial. So once you distribute the monomial to each term, then you're going to multiply each pair of polynomials. After that, you'll combine like terms and put your answers in standard form. Remember, guys, when you're combining like terms, you do not add exponents. When you are multiplying like bases, you add exponents. So really watch yourself because that's where I see students make mistakes. And as always, at the end of everything we do this unit, make sure your answer is in standard form. Okay, let's practice this. So we have this negative 2x squared here. So I'm going to be distributing it to each term after the polynomial. So let's just, for this first one, write out basically what I'm going to be doing kind of in my head from now on. So I'm taking negative 2x squared times 3x squared. I'm taking negative 2x squared times negative 7x. And I'm taking negative 2x squared times 10. So now, this is kind of like back to homework 2 of this unit. All we're doing is multiplying these two monomials. So when we do that, I multiply the coefficients. That gives me negative 6. When I multiply things of like bases, I add the exponents. So this becomes negative 6x to the 4th. Next, I'm going to look at this next polynomial. I have negative 2 times negative 7. I am multiplying those coefficients. When I do that, it's going to actually become positive. And I'm going to get positive 14 and then x. Remember, that's the same as x to the first. So when I multiply those like bases, 2 plus 1 is going to give me 3. Remember, if I'm going too fast at any point, pause the video and take a look at what I'm doing. Next, I'm taking negative 2 and I'm multiplying it by my constant of 10. So negative 2 times 10 is going to give me negative 20. I want to make sure I keep that x squared there as well. That x squared needs to stay. We're not leaving out any monomials when we do this. Okay? So then your final answer is this guy right here. I know it's my final answer because all my like terms are combined and my answer is in standard form. I'm done on this one. Let's take a look at number 2. So number 2, instead of writing out this step like I did over here, I'm just going to kind of do it in my head. If you still need to write it out like I did over here, go ahead and do that on your notes. That's fine. Okay, so what I'm going to do is I'm going to multiply 5a squared times negative 4a squared. So 5 times negative 4, I'm going to multiply those coefficients to get negative 20. Then I want to multiply things with like bases. A squared times a squared, 2 plus 2 is 4. The next thing I want to do is I'm going to take this 5a squared and I'm going to multiply it by 2a. First I multiply the coefficients. 5 times 2 is 10. A squared times a to the first, well 2 plus 1 is 3. Last thing I want to do is I want to multiply this coefficient or this monomial out here times that constant at the end. Well, 5 times negative 7 is negative 35. And then remember, I don't want to leave out that a squared. Even though I'm not multiplying a squared by anything, it still needs to be in my final answer. I don't want to lose any of my monomials or any of my terms as I'm going through here. So this is how we're going to start, okay? Some of it is just going to be straightforward. Can you multiply a monomial into a polynomial? So I'm going to have you guys do right now is I want you to try these two on your own paper. If you need to go up and check your answers, you can. Okay, so just check those on your own. And then remember, these are important ones to do because they might show up on the quiz later. Okay, so Let's talk about the steps when we are simplifying expressions. So the first thing is really similar to what we were doing previously on the front side. We're distributing the monomial into each term in the polynomial. Okay, so once we've distributed, that's when we multiply each pair of monomials. So if we look at something that we're simplifying, once we've multiplied each pair, then we're going to move and we're going to combine like terms. We always want to make sure when we're done with, before we're done with anything, that we combine those like terms. And by combining like terms, we usually can get it into standard form. Remember, you want to have your exponents from largest to smallest. So let's try a couple of these. Let's try number 4. So for number 4, what we're going to do is we are going to start by distributing. So I want to take, sorry, we're on number 5. I want to take this 4 and I'm going to distribute it into each thing. Notice I'm only distributing it into the parenthesis that follows it. Same with this negative d. I'm only distributing it into the parenthesis that follows it. So let's go ahead and take a look at what that's going to look like. So to start off with, I'm going to take 4 times 3d squared. First multiply the coefficients. So 4 times 3 is 12, and then we get d squared. Next, I'm going to take 4 times 5, which is going to be 20, and then I still have that d. So all I did was take that 4 and multiply it by the coefficients. Next, what I'm going to do is I need to take this negative d and multiply it by each thing in that parenthesis. So to start off with, I'm going to take negative d times d squared. When I take negative d times d squared, d to the first times d squared is going to be d to the third. All I did was add those exponents, and it's going to stay a minus sign. Remember, you can always think of this as having a negative 1 out front if you need to. So the negative 1 times negative 7 is going to give us a positive 7. And then we also have d to the first times d to the first, so 1 plus 1 is d squared. Lastly, we have negative 1d times 12. So we're going to have a negative, and it's going to be 12d. Don't ever forget those letters. Even if you're not multiplying it by anything, it still needs to be multiplied in at the end. So now I need to go through and I need to combine like terms. So I have negative d cubed is the largest exponent I see, so I'm going to write that first. So I've taken care of that one. Next, I see that I have 7d squared and 12d squared. So because they're both d squared, I can combine those like terms. So I'm going to add the coefficients. 12 plus 7 gives me 19. And I'm going to write d squared. Again, when we're combining like terms, we do not add the exponents. So now I've taken care of those. Next, I see I have 20d minus 12d. Well, 20 minus 12 gives me 8d. So I check, all my like terms are combined, my exponents are in standard form, I'm good to go. Let's practice again on number 6. So for number 6, I'm going to distribute in this 3. I'm also going to be distributing in this x, or opposite of x. So let's start off by distributing that 3. I'm going to take 3 times 5x squared. I do that by taking 3 times 5, which is 15, and then I still need to have my x squared. Next, I'm going to take 3 times 2x, so 3 times 2 is 6, and that's going to give me 6x. Lastly, I'm taking 3 times negative 4, which is going to give me negative 12. Next, I want to distribute this negative x into the polynomial that follows it. So I have negative x times 7x squared. So negative 1 times 7, remember there's that invisible negative 1 out there. Negative 1 times 7 gives me negative 7. X to the first times x squared is going to give me x cubed. Then I have negative x times 2x. So that negative out front is going to give me a minus 2. X to the first times x to the first is going to give me x squared. Lastly, I have negative x times negative 3x. Those two negatives are going to make it a positive, and that becomes positive 3x. So the last thing I need to do before I'm done is put my answers into standard form. So I see that this negative 7x to the third is my largest exponent, so I'm going to write that first. Next, I have 15x squared minus 2x squared. I can combine those like terms to give me 13x squared. Remember, guys, I'm not adding any exponents when I'm adding like terms. Then I have 6x plus 3x, so I get plus 9x. and then I have minus 12 at the end. So all my like terms are combined and my answer is in standard form. So that right there is my final answer. So I'm going to have you guys go ahead and try these two on your own. If you need to check your answers up front, you can. We'll talk about these as a class. Again, these are the problems that are most likely to be on the quiz. Okay, let's set up this word problem. What I'm going to do is I'm going to set up this word problem and I'm going to solve it for you. And then I want you guys to try and set up and solve number 10. Remember, if we don't practice word problems, if we just leave them for Miss Humbert to do, we're never going to get any better at them. So for number 9, Greg pays a fee of $20 a month for local class. Calls. That should say calls. Good job, Miss Humbert. Everybody give her a high five for that one tomorrow. Okay? So, local calls. Long distance rates are 6 cents per minute for in-state calls and 5 cents per minute for out-of-state calls. Suppose Greg makes 300 minutes of long-distance calls in January, and M of those minutes are in-state calls. Find the expression for Greg's phone bill. So what I'm going to do is I'm going to let B represent what my bill is going to be. Okay? So, before I do anything, before I use any minutes, I have to pay $20 to start off with. Okay? Then I know that M represents my number of in-state calls. So let's take a look. It's 6 cents per minute for in-state calls. So for every M minute that I call, I am paying 6 cents. Okay, so I'm putting it all in terms of dollars. Oops, that would be 60 cents. Miss Humbert's on the bad track today. So there's our 6 cents. Okay, well now, I don't know how many minutes I spent with in-state calls, but I know the total number of minutes. So how many out-of-state calls is going to be the total number of minutes, which is 300, minus the M minutes that are in state. So I'm going to have 300 minus M. And that represents my out-of-state calls. And those cost me 5 cents. That's 0.05. So now I'm going to go through and simplify this. This I can't do much about right now. I can take this 0.05 and I can distribute it in though. So 0.05 times 300 gives me 15 minus 0.05 M. All I did was distribute in that 0.05. Last thing I need to do is combine like terms. Well, let's look at this first. 0.06 M minus 0.05 M is going to give me 0.01 M. These two terms have been combined. Then I have 20 plus 15 is going to give me 35. So my bill will be represented by this equation right here. Okay, so however many in-state calls I do, in-state minutes, there we go, that I use, I can use M to represent that and calculate my phone bill. So that concludes this video. I want you guys to go ahead and try doing something similar for this number 10. It's set up the same way, so use what you did on number 9 to set this up. Okay, so this concludes your video. Go ahead and grab your homework when you're done taking the quiz.